Ora si registrerà la conferenza.
Bene, buongiorno a tutti, sono Gianmarco Moroni, sono le 16 in punto, iniziamo questo webinar dedicato all'ispezione ottica digitale che teniamo in collaborazione con Inspectis. Come sempre inizialmente faccio due chiacchiere, la prima vi chiedo la gentilezza di autogestirvi l'audio. Io posso sicuramente disattivarlo, ma se lo fate in autonomia, soprattutto quando parlo, mi fate una cortesia. Il webinar verrà registrato, quindi sarà disponibile nei prossimi giorni, vi manderemo il link per poterlo riascoltare e rivedere nel messaggio di cortesia. Aspettate che ho un messaggio. Ok, come dicevo, il webinar di oggi è organizzato con un nostro storico fornitore svedese che si chiama Inspectis. Iniziamo. Ok, intanto per chi mi conosce o per chi si vuole collegare con me, io sono Gianmarco Moroni, sono il presidente di Butterfly. Sotto alcuni link per collegarvi con me, con l'azienda, sempre sul profilo di LinkedIn, o per vedere l'agenda dei webinar sempre aggiornata che c'è sul nostro sito. Butterfly è una società totalmente privata, costituita nel 2002, con sede vicino all'aeroporto di Bologna e diciamo seguiamo principalmente le aziende che si occupano di fare ricerca e sviluppo elettronica, produzione e assemblaggio di elettronica, enti di ricerca e didattica, enti governativi, manutenzione di impianti industriali e sempre grazie al nostro sito possiamo fornire una larga parte dei prodotti che commercializziamo anche agli utenti privati. Per comodità abbiamo diviso, diciamo così, l'offerta in due macro cataloghi, uno appunto più dedicato alla strumentazione di misura, sistemi pre-compliance e termografia, e uno dedicato ai sistemi di protezione antistatica e ai sistemi di saldatura manuale, oltresì ai sistemi di ispezione ottica, di cui ci occuperemo oggi. Ecco, una cosa molto interessante, un paio di settimane fa c'è stato lo Zero Emission insieme al Power for Tronic, non sono proprio delle fiere, sono dei forum, però è stato il primo evento dopo quasi 2 anni di eventi digitali. Vi confermo che c'è stata un'ottima affluenza di persone che ci ha rincuorato parecchio. Ovviamente abbiamo altissime aspettative per il Coitec che ci sarà a fine settembre e vi do la conferma, le date sono già fissate, dalla prossima settimana ci sarà un form di pre-registrazione, a ottobre faremo 2 settimane di seminari itineranti, penso che sarà la prima e la terza settimana di ottobre e quindi insomma tenete d'occhio il nostro sito per essere aggiornati su queste cose. Ecco, io la mia parte l'ho terminata, Alistar si era collegato, ha avuto una telefonata urgente, vediamo subito se è disponibile. Alistar, can you hear me?
Yes,
Hello,
indeed.
Alistar?
I hear you. You can
Are
hear
you
me?
ready?
Yes, I'm ready when you are. So you can.
All right. So thank you very much for joining the webinar of today and supporting us with your job.
That's perfect for me.
I'm going to give you the role of speaker so you can manage your PowerPoint and so on.
Okay, wonderful. I will take over when you give me the cue.
You should be ready.
Okay, so I can. Right. Okay. I need to go into. I need to go into presentation mode here. So.
Okay, so I deactivate my audio. In case of need, I will jump in. Thank you very much. Have a good work. See you later.
Very good. Good. Right. Well, good afternoon. Thank you for attending. GM asked me to present something around our 4K products, and the constant question we get asked is, why do we need to use 4K? So 4K or not 4K? That's the question for today. Anyone today buying a TV or a mobile phone will see this label plastered everywhere in electronic shops, 4K Ultra HD. Well, what is that? What does it mean? How does it apply to video microscopes? Inspectis, we've been making video microscope products for the last 5 years, and we now have a full range of products, both with full HD, ultra HD, and even the older HD standard. So what is so good about 4K? What's the big deal? Why should you be interested in buying a 4K inspection system when most of the products on the market are clearly full HD or less? What makes it worth spending perhaps a bit more money on a 4K system? Well, first of all, the basics. What is 4K? What are the advantages of using it? Are there any disadvantages of using it? And how does it apply to video inspection tasks? And you can ask, when is it best to use 4K? We get those questions all the time. So I try and answer a few of these more fundamental questions. What is 4K? I'm sorry if I'm teaching you if you already know this, but to a lot of people it's not totally obvious. The term 4K is referring to the number of pixels in the horizontal dimension of the frame, the video frame. The standard format for video these days is 16:9 ratio. If any television, most monitors these days, and even a lot of laptops come in that format. 16:9 gives you a good balance between width and height, and it's very preferred by sensor manufacturers who are selling bulk to cameras, all sorts of different applications. So that's what you generally get, is a 16:9 ratio. Now, full HD, the most commonly used type of camera these days, is 1920 pixels wide by 1080 pixels high. 4K, or Ultra HD as it's commonly known too, is basically double the size of a full HD. And simple arithmetic means that by doubling the width and doubling the height, you also get 4 times the number of pixels. So simple arithmetic again means that a sensor for the 4K cameras is using 8 megapixels versus only 2 megapixels for a full HD system. I could have mentioned HD as well. In maybe 5-10 years ago, there were TVs HD ready. They were usually 720p. And these correspond to about 1.4 megapixels. So immediately there is an obvious answer to the question, what is 4K and why is it better? It has 4 times the number of imaging pixels. So that's a lot more information, a lot more detail, a lot more resolution potentially on any image or any video stream. And that is a big deal. Having got that far, what are the advantages of using 4K? And what are the possible disadvantages? So I'll try and answer that. It's not just the number of pixels. If you are a photographer or know anything about the development of digital photography, you will probably understand that just having a lot of pixels doesn't mean necessarily the image is better. You can buy a top Nikon camera or a top Canon camera for professional use, and it will have less pixels than a camera sold to amateurs and enthusiasts. So it's not just as simple as having more pixels. The sensor size is a major factor in the image quality that you see on the screen. Basically, having the same number of pixels on a larger size sensor is going to be better because the distance between the pixels can be bigger, and that can give a much better dynamic range, and hence contrast. All these other factors that affect imaging can be better. But another major and very important thing when we design our cameras or microscope cameras is the quality of the optics. There's no point in having a high resolution sensor if your optics can't resolve light to match the performance of the sensor. So a lot of these other factors, apart from the number of pixels, will influence how good the image you see on a monitor or a computer are. And on that latter point, the system electronics are a vital part of a digital system. So the way the image signal is processed and computed and then presented on a monitor is also a very important factor. So along those lines, Inspectis always aims to make our devices to give the best possible imaging and processing performance. That's where we start from. All of our cameras, the image comes first, and that is a combination of picking the best camera sensors, designing the best optics, but also utilizing high quality electronics inside the cameras so that nothing is compromised from the image point of view. So a qualified answer to the question, is it an advantage to use 4K, is yes, it's certainly a good idea. 4K images basically provide more detail and information so long as the optics and the image processing are compatible and of high enough standard to match the 4K resolution. Are there any disadvantages? Well, actually there are. And we're very straight about this. The amount of information, the digital information that comes out of one frame of image is multiple times more than the same frame image from a full HD system. So any system that is taking that video stream and processing it in any way is going to have to be able to handle vastly higher rates of data and faster, because for any video, one of the main dictates of the image video stream quality is how many frames per second there are. And most full HD systems will work at 60 60 frames per second. So that's where the P comes from in 1080p is a progressive frame. You get one frame every 60th of a second. There were older systems called 1080i where you combine 2 frames, and this is the old interlaced system, which have more or less died out. So you've got to handle the information in 60 frames of video per second and process it and put it onto the screen. Actually, the disadvantage currently is that a lot of electronics, computers, and so on simply can't handle that amount of data so quickly. So whilst you can put it straight onto most monitors, 4K monitors, you could achieve higher frame rates. The cameras themselves generally currently are limited to around 30 frames per second. Now, that's not a problem for most inspection tasks. The eye can't detect that frame difference. And if you're doing any form of work under a camera using, say, a soldering iron, for example, there won't be any visible lag at 30 frames per second. If you went down to 20 frames per second, then there would be a problem. But 30 frames is an acceptable video standard. In future, I dare say this will improve and there will be faster, 60 frames, even higher. And on some mobile phones, you see even 120 frames per second 4K video. So the electronics will follow eventually. So how do we apply a 4K system and get the best use out of it? You know, why is it useful? With all other factors equal, the image quality is going to be inherently better simply because you have, 4 times the number of pixels. I keep saying this, but that's the basic fact. You've got 8 megapixels active rather than 2. So you're going to see more detail. And if you use it as a microscope and you zoom in to look at detail, every pixel in a 4K image will represent a smaller length and height than the same pixel in a full HD system. So if you apply the image and do measurements or comparisons, each pixel is smaller, so you get better measurement resolution, basically. And I can illustrate that with the next slide, just to show you the difference. If you take our 2 main products for 4K, the U30 or U30S, we have different formats, and compare it with the full HD equivalent, which has very similar optics, very similar zoom, magnification, and other properties, but one is 4K and one is full HD. The field of view, when you zoom into the maximum zoom, which is 30 times on these products, the maximum magnification on a U30, it's 9.9 by 5.6 millimeters. On an F30, it's very, very similar, 9.3 by 5.2. But if you divide those distances by the number of pixels, what you see instantly is each pixel represents 2.6 microns on a 4K versus virtually double that on a full HD system. So you're getting half half the size represented by each pixel. The resolution is twice as good, basically. So that is the key advantage. When do you actually need that, though? That's the next. Oh, no, it's not the next question. The video handling. We're talking about practical use of 4K with video inspection. The video handling has an important fact. Do you just want to couple the camera to a monitor and use it for basic video inspection? In that case, there are absolutely no negatives at all. It's only positive. Even with the slightly lower frames per second, if you're just looking at inspecting any object, whether it's a circuit board, a mechanical part, you're going to see more detail. So that's good. If you're using the camera as a magnifier to do some sort of task, it could be some rework on a board, it could be making a precision mechanical part. Anything like that under the high vision is going to be better because it's clearer, more resolution. And so the only time, whoops, gone back. Sorry, I didn't mean to do that. The only time where you've really got to think about it is if you're transferring the information and processing it. And by that, I mean, basically you're pumping the video stream into a computer to either analyze the image in some way. You want to feed it into some software to do measurements, to save images, capture images, video, that sort of processing. The demands of the 4K, as I've mentioned earlier, are higher on the hardware. So you've got to have faster clock speeds, more powerful processors. You certainly can't use USB 2. The minimum is you need to use is USB 3 devices to handle that frame rate and that data. So that means buying higher quality computers, monitors, etc., which cost a bit more money. So that is understandably a factor in the choice. When is it best to use a system with 4K? Well, there's no straight answer to that. It depends on other factors, why you want to use it in the first place. If you just want the best image, the best equipment, oops, I've pressed the, sorry, something has gone haywire. I think I hit the mouse by mistake. Let me just get back to where I was. Yeah, I mean, if you want the best of anything, you buy the best performance, whether that's a car, a camera, computer. So if you want the best video inspection system, buy a 4K system. No other question to answer. But do you really need it is another question. And to answer that question, you really have to look at the fundamental questions we ask any potential customer, irrespective of the product. It's, you know, what are you wanting to look at? What are you going to inspect? And the next questions, what is it you're looking at? How big is the object you're looking at? And more importantly, how small is the detail you need to see on that big product? And we have customers, you know, they come to us, they have an object that's 1 meter by 0.5 meter. And if all they want to do is to look at the overall appearance of this panel or board or whatever it is, maybe a general full HD system is perfectly adequate. But as soon as you want to see small detail, however big the product object is, if you want to see the small detail, the higher resolution you have to look at it with, the better. So a 4K system is always going to win out over a full HD system. Now, we're talking about electronics, and this little panel is a really excellent example of surface mount components that are, I was going to say commonly in use. I mean, the smaller sizes here illustrate just how small, and if any of you have handled these products, they're almost like dust to look at. Here we have a system, I've used a full U30 system with a +5 lens, I think. No, maybe not. This is just basically using the camera as it is. So you can see the components from 0402s right down to these dust-like components. Now, I say right now, showing you a slide over the internet on a web conference system is not going to be totally representative. You're never going to see just how good the image is without seeing it live. Most of the, well, virtually all these web conference services don't have the possibility to network 4K transmission anyway, so we can't do that. But I can compare this image with a full HD image of the same panel, and it's a little bit difficult, as I said, over the web to show you this, but you can see very obvious degradation in detail, even at the 0402 size. When you get down to the very tiny 008, 004s, the difference is very, very apparent. If I put them side by side, I've just extracted those bits. I hope you can actually appreciate some of this, but you can see a lot more detail in the gold plating on the gold track here. You can see a lot more detail of the solder fillets and the particles. And you can actually, on the 008, 004s, you can actually see the at some detail, whereas on the full HD it looks like a grey blob, if you're quite honest about it. And I've zoomed in on the same images, and it gives some feel, but it's not really totally representative. So we always say seeing is believing, and I honestly say if you're interested in seeing how impressive the 4K imaging is, you've really got to see it live. And Butterfly will be very pleased to arrange some demo to show you up front with your products. We will also be at a number of exhibitions. Now they are starting to happen again. The latest we know is that Productronica will be on, and we have a stand booked for that. And Gianmarco can tell you more about the activities in Italy we have planned as well. So a summary, if you like, for the 4K. if you're looking at components smaller than 0402s, then 4K will undoubtedly be an advantage. And if you're planning to do any form of reworking on components 402 or smaller, absolutely 4K will be saving you a lot of hassle and hopefully eye strain as well. We have customers who regularly rework prototype boards with 0201s or smaller even. And that's quite a typical application for reworking, is in prototyping, development boards and so on. Special military aerospace boards, very expensive to just throw away. They need repairing. This is one application very strongly in favor of using 4K. The other thing to not overlook is if you want to provide the best possible documentation and results, doing measurements and best possible quality control, then naturally using a 4K system is going to be better than using a full HD system. But there are conversely situations where, you know, if you're looking at boards with fairly large components, large spacings, a full HD system will often be perfectly adequate. You know, so it's a balance between performance, but especially what you're looking at. Can't emphasize that more. Now, in the time remaining, I just want to just run through briefly, just to give you a quick overview of where the 4K products fit in with our overall product range. But if you're choosing any system, the same old questions need asking. You know, how big is it and how small the detail? Those answers will also affect not just whether you choose a 4K system or a full HD system, but they're also very relevant to choosing the right magnification, choosing the best camera stand, or deciding how to handle the object under the camera. Do you want to move the camera to look at a big object? Often that's the best solution, is to move the camera. Or do you want to move the object under the camera? I'm happy to say that Inspectis has a range of products that basically can be configured to put the camera and the object together in virtually infinite combinations. So no, as they used to say, no task is too small for Inspectis. So whether you want a 4K camera, full HD camera, we have a very diverse range of stands, lenses, object handling equipment, different lightings, different lenses. We can combine those to do the job. If we just look at the products from a, point of view of the resolutions we offer, we still have a product, the C12, for HD. It's still a very powerful product. It has a very large sensor, so despite the lack of pixels, it provides a very strong, sharp image. Full HD, we have a whole range of standard working distance and long working distance products, and I'll mention DIM in a second, and the same is applicable to the 4K. So we have virtually a mirror range of products for 4K and full HD. And as I said, all those products come in the standalone format, which you see the cable, but these cameras can be mounted on any one of the range of stands. For some applications where you don't need that flexibility but still want the best image quality, the all-in-one solution is often a very good alternative. And then for specialist applications, especially working on reworks where you want to have maximum height between the camera and the object, our long working distance range of products are very well used all over the place. Sometimes people build these cameras into their own housings and machinery, workstations and so on. This year we've introduced a completely new concept for digital microscopy, and we announced in April the first digital inverted microscope system. Again, both in 4K and full HD systems. And these have optics that can take you with the images up to 250 times on screen. These are ideal for very flat objects. The first application we've been working with is actually looking at polished weld samples, but these could be used for looking at virtually any objects, whether it's in biomedicine. We've got a company this week evaluating it for looking at seeds. You could use microelectronic boards, microcircuits, that sort of thing. This is brand new. We'll be very happy to talk about it. The U30 and the U30S, this is what we've been talking about, 4K. These are a core product and they are available with a lot of additional features. You can add laser pointers. We can make them extra ESD safe. I just I won't dwell on this. This is just to show the range of magnification and the resolution possible. We can share this information afterwards. You can see with the right lens, you can go up to a screen magnification of 600 times. The full HD systems are still a great workhorse and widely used throughout the industry. They offer the same possibilities, ESD protection, laser pointers. One of our most popular uses is mounted on a XY system on conveyor belt systems. These are very convenient for systems, online inspection, e.g. post AOI type applications where you want to check. And that stand helps you to quickly locate the area of interest and look at it in detail. We have around 9 different ways of controlling a camera. So every camera comes with the top controls, which give you basic brightness, zooming, color balance. But we have a whole range of remote controls and of course computer software controls. And again, all these work for both full HD and 4K. Image capture is probably the most complicated issue when it comes to 4K. Due to the amount of data, there are basically no simple devices obtainable at the moment that can just, at a press of a button, save an image to a USB stick or something. We have those for the full HD, and these will actually work with the 4K product, but will compress the image down to a 2K image. If you simply want a reference picture or an illustration, maybe that is a good solution, but if you want the very best imaging, then you absolutely need to consider using a PC to capture the image. And we do a very wide range of software, from a basic software that is good for capture, very basic notation, to the top of the line system, the Pro X, where you can benefit from focus stacking, a whole range of overlay features, and a comprehensive measurement and documentation capability. So this is a Pro X, just shows the number of tools. You can import a DXF file, for example, and use that to configure an overlay, so you can compare your live image with an overlay. That's just one way of doing it. We can discuss these in more detail. This is just to illustrate the range of add-on lenses. Any of the cameras you can add from a +1 even up to a +56, which is more like a microscope lens. And as I said earlier, it takes you up to 600 times. I would say that's an exception. The majority of users are using either the basic camera, or maybe a +5 is very good for electronics, because that gives you the equivalent of a 40x stereo microscope. So without a lens, you're getting roughly 10 times optical magnification, same as a low power stereo. With a +5, you're getting pretty equivalent to a times 40 optical microscope. Lighting is immensely important, and we've designed a range of products that plug directly into the camera, so they're powered. You haven't got to have extra wires and power supplies messing up the scene. And handling of objects has always been a primary concern for us. Our XY tables are sold to many people outside our business just because they want an XY table. And probably one of our most well-known capabilities are these customized XY stands that can be integrated into racking or production lines. Very versatile. We do supply a number of kits to make the choice a little bit easier. It can be a bit daunting, which camera, which stand, which lighting. So we have configured a number of kits that offer some nice pricing and cover a vast amount of standard tasks. And finally, I would like to emphasize Inspectis quality. We sometimes have this strapline, quality of inspection. We as a company are certified and operate under 9001 ISO. And we also make, I'm not covered at all here, we make some medical products, which are basically medical devices used for microscopy of capillaries in the blood vessel system. And these are fully qualified medical devices made to 13485. So this is if you're not familiar, is basically a much higher standard of 9001. But the overall business way of working is essentially rooted in good working practice. We aim to provide and design the products of the highest quality for your inspection tasks. So I'm happy to finish there. Gianmarco, if you would like to take back control. I don't know if anyone wants to ask any questions, but
so first of all, thank you very much. I think it was very clear, and often starting from the basics, it really helps, you know, to clarify some points.
Good. Well, it really isn't rocket science to understand why 4K is better, but we do have customers. It comes with a price. You know, when you want the better quality on anything, it's going to cost a little bit more. So what makes that worthwhile? So,
of course. So let me switch a bit in Italian. So I'm going to explain what happened 10 days ago at the show. I believe is important.
Okay.
Una decina di giorni fa. No, don't worry, it's okay, leave it like this. Una decina di giorni fa abbiamo, come dicevo prima, fatto questo evento a Piacenza, lo Zero Emission insieme al Power for Tronic. Non so se qualcuno di voi ci è venuto a visitare, ed avevamo un sistema 4K Inspectis collegato ovviamente a un monitor 4K insieme ad oscilloscopi, sistemi bidirezionali, eccetera, eccetera. E vi posso assicurare che il sistema di visione Inspectis è stato probabilmente il prodotto che ha attirato il maggior numero di persone a fare domande, vedere effettivamente, vederlo dal vivo piuttosto che ovviamente online, dove anche lo streaming non permette di vedere le difficoltà, è tutta un'altra cosa. Ed è per questo appunto che poi siamo attrezzati per poter fare demo, spedire le unità presso di voi. Nicoletta, la mia collega, è la responsabile di questo, e quindi insomma vi possiamo aiutare in questo modo. Sicuramente al Coeltec a fine settembre lo avremo con noi, e per chi di voi partecipa ai nostri seminari, ai nostri eventi, avremo sempre comunque un'unità 4K con noi da poter provare. Però effettivamente, a differenza magari oggi di uno strumento che con il web server si collega alla rete e si riesce a vedere praticamente tutto ciò che fa, con questo tipo di strumentazione sicuramente l'incontro, o quantomeno la demo in autonomia, quindi spediamo lo strumento e uno lo prova, cambia veramente molto la sensazione, perché ovviamente quando magari i prezzi iniziano a salire sopra i 4-5 mila euro, ovviamente ci chiediamo se l'investimento ne vale la pena. Diciamo che se si ha l'applicazione che richiede degli ingrandimenti o visualizzare cose molto piccole, avere a disposizione una macchina 4K vi cambia la giornata, insomma. Ecco, questo è quello che ci tenevo a dire, senza voler sviolinare, ma effettivamente è effettivamente così. Ora, se qualcuno di voi vuole fare qualche domanda, lasciamo qualche minuto libero, altrimenti è il momento dei saluti. Vi ringraziamo e noi abbiamo il prossimo webinar giovedì. Lasciamo un attimo di tempo per chi volesse parlare, si può attivare l'audio o scrivere in chat, e dopodiché, se non arriva nulla, vi salutiamo. Ok, sembra che domande non ci siano. So you are lucky, no questions. So you were perfect, you know. Va bene, grazie, thank you very much again, Alistar. Grazie a tutti per la partecipazione. Vi ricordo che il webinar è stato registrato, quindi riceverete appunto nella mail di ringraziamento il link per poterlo rivedere. Visitate il sito butterfly.com per l'agenda sempre aggiornata dei webinar. Grazie ancora e buona serata a tutti. Arrivederci.
Thank you, bye.